My name is Vikram Anand Bhushan and I'm a co-founder of Hypermine technology. So today we are going to demonstrate an authentication system based on blockchain, Hypersign, which is like a single sign-on solution on blockchain, could be used for decentralized or centralized application. Why we came up with this solution? So the current problem in the authentication system is that we are storing all our credentials on the server itself, or we are using a third-party API to validate for us. When we are saving the credentials on the server, it makes it prone to attacks such as brute force, etc. So now to solve this issue, we tried to come up with an authentication flow using blockchain technologies such as Ethereum. The complete flow works in two steps. So before I explain the step, I would like to tell you what Hypersign is. Hypersign is a blockchain-based single sign-on solution that enables users to securely access applications without providing their access credentials. A user will not have to provide their access credential to the authentication server. But how we do it, we are going to explain in the next slide. By embedding a blockchain algorithm in the mobile application and enabling user to authenticate without the use of login credential. Basically what happens, the application server does not store user data, rather it relies on the user's private key and public key stored in the user device. And the device could have a cold storage facility also in order to make it more secure. So basically a cold storage is a memory space or a hardware which is not directly embedded into the operating system. So if somebody tries to hack that operating system, he will not be able to get the access of that. So if we are storing our private key there and we only activate it when we are using it, that way it's a little bit more secure. And in the crypto world, it is called as cold storage. Memory space embedded in the mobile itself, or it could be an external device. So now I'm going to explain you how this flow works. It's divided into two steps. In the first step, user will register themselves on the app. User gives his credential, not credential, his details like email ID, password. Just that is just for the app, mobile app, not for the authentication itself. So user ID, email, and some other details. What we do, we have a light node of Ethereum embedded in the mobile app itself, and basically we have a blockchain embedded in the mobile app, and we use some of the features of that blockchain to generate a public key and private key. So using the Web3 protocol, we will create an account and we will generate a public key and private key from that. So using a Web3 protocol, we will create an account and then we will generate the public key and private key. We are going to store the private key into the user's device, or it could be a cold storage as well, as I've explained before. And we are going to send the user details plus the public key to the application server and the public key to the authentication server. So now our authentication server is also a light node of Ethereum. So I'm going to explain you how it is going to validate the user in the next step, which is the final step of the flow. We are going to demonstrate the login system. When a user has to log in into the application, he's being shown a QR code on the login screen. So user can scan the QR code and the string behind the QR code is taken into the mobile app. So using the user's private key plus the string that we have got, we generate a new transaction. We sign a transaction basically using the sign transaction method of Ethereum. So this transaction will be signed with the private key and the string coming from the QR code. Now we are going to send the signed transaction plus the public key of the user and the QR code to the auth server to validate. Now auth server is also running a light node of Ethereum. So auth server will first check if the public key exists in his database or not, in its database or not. And if the public key doesn't exist, it responds back with an invalid user. If it exists, then it is going to validate the transaction. So it is going to use the validate transaction method of Ethereum to do this task. And if the using the public key, it will validate whether the transaction was signed right or not. And if it is correct, it is going to send a signal to the app server to redirect it to this public key address. App server can use the public key to match it into his user details table and redirect back. So this is a basic flow of how we are going to solve the problem of not taking user's credential in our auth server and storing it in the server. So without taking user's credential, we are able to authenticate our users. So we do understand that we have only scratched the surface of what blockchain technology can do right now.